This lesson is going to investigate finding sides with sine, cosine, and tangent, which you may remember as SOHCAHTOA. The objectives for this lesson are to determine the trig functions for given angles using sine, cosine, and tangent, and to solve for unknown sides using the correct trig function. You will find this section in the Mathematics for Machine Technology textbook in pages 411 to 433. It has been condensed for the purpose of this lesson, and you are not required to have the textbook at home. There is sufficient material posted. So we're going to begin with labeling our right triangle. We've already looked at this when we looked at Pythagorean theorem. So you have this angle is very, very tiny here, but we have our angle down here in the corner, our theta. So that's the symbol we often use for angle. So we're going to be talking about this angle. I'm going to call this our subject angle. Okay, I have a hard time talking and writing at the same time. Sorry, it slows me down sometimes. So we have a subject angle. We also have a right angle that is different. So we're going to label our sides relative to these two. Now, some of the names will be the same. And as you remember from your last lesson, the side across from or opposite the right angle is always the hypotenuse. So that hasn't changed. How do we label the other two sides? Well, we're not going to label them with A's and B's anymore. We're going to label them relative to the subject angle. So we look at our subject angle here and we say, well, this side, the far side, it's across from the subject angle, so we're going to call it opposite. We'll often abbreviate that with O. The angle, the side next to the subject angle or right beside it, we call adjacent. That simply means next to, and we often will abbreviate that with A. Hypotenuse will be abbreviated with H. So we have three sides. Hypotenuse is always opposite the right angle. We have our subject angle. Next to it is the adjacent side, and opposite the angle or across from the angle is our opposite side. If you can do those three labels, you will succeed at any question. The key is getting those labels done correctly, and I recommend putting O, A, and H on each question that you solve. So what do we use them for? Well, if you've already, I posted a little video from a machine perspective, so hopefully that's providing you with some insight. The sine ratio is just the ratio of two sides of your triangle. We often refer to it, you'll see it written as sin or sine, S-I-N on your calculator. So that's what that button option happens to be. But when we use little acronyms to remember these ratios, we'll often say sine is represented by SO, S-O-H. S stands for the sine ratio, O stands for the opposite side, and H stands for the hypotenuse. In the triangle, up at the top here, you'll see our two red lines. Those are the two sides that we're looking at. We have hypotenuse and opposite. Those are the two sides that we make a ratio with relative to our subject angle when we're finding sine. So the sine ratio with a sine of an angle is going to be equal to the opposite side divided by hypotenuse. That's where S, O on the top, H on the bottom. Cosine ratio, if we look down here, it's represented in our acronym as CA. I often use the acronym SOHCAHTOA. So it's our CA. C for cosine, A for adjacent, you'll see it uses this side next to, and H for hypotenuse. Cosine ratio is always adjacent and hypotenuse. So the cosine of an angle, and I'll show you a little bit better way to write these, because usually we would put the symbol for angle after cosine, but just for the sake of space, I'm just going to pop in what the ratio is. Tangent is represented with tan, and the tangent ratio we see here, we use the acronym TOA. So we get SOHCAHTOA. There's a couple different ways to remember it. I'll give you those in a moment. But tan uses O for opposite and A for adjacent. And we can see that in our triangle. It does not include the hypotenuse. We don't even care about the hypotenuse. in this particular case. So depending on which two sides we have information about, or what side we want information about, we can use these three ratios to find their lengths or to find the angle that connects them. I would strongly advise you to remember the acronym SOHCAHTOA. I've used math for dozens of years. I've used this section over and over. Partially could be a little bit of a dyslexic thing, but I find it really helpful to write SOHCAHTOA on the top of my page whenever I begin. What it does is it's going to allow us to use a process of elimination to decide what is it we want. Now, there are a couple ways. SOHCAHTOA is how I learned it. Some people have learned the ratio as old houses always have old attics, and it's in the same order as you see on your calculator. So this would be sine, this is cos, and that's tan. I have heard another one. I learned it when I was teaching in Kensington at the high school there. Apparently it's not unique to that school. For S, instead of SOHCAHTOA, they make up a sentence with it, and it goes like this. Some old hippie caught another hippie tripping on acid. So you can use whatever you want to help you remember those ratios, but you will be expected to know how to work with them. And I find remembering that word SOHCAHTOA and just writing that on the top of your page makes a big difference. So we're going to put our calculator. I want you to first check is your calculator in degree mode. So how you're going to check, depending on which calculator you have. So I have my two favorites. So up at the top of the calculator, this is the same calculator that's recommended for the block. Mine happens to be gray. You have a white version, but you'll see up on the top here, it says DEG. That DEG tells us the calculator is in degree mode. If your calculator is not in degree mode, it may say rad or grad up there. To put it in degree mode, you are going to push the mode button, and then you'll look up here in this little box, and you should see the first one says DEG. So you're going to press mode and then 4, and that will give you that degree code. It's really important that your calculator is in degrees for the calculations, or you won't get the same values. We're going to do a check in a moment. If you are using a calculator that's more like, I'll confess, this one's my favorite one. It has 2 lines, especially when I'm teaching in front of a class, because it lets me cheat a little bit. I can see, I don't have to remember what I typed last if I get distracted. This is not the calculator you get on your block. So make sure you know how to use the block calculator. That's really important, and it's going to be a little bit different. I'll tell you how to key things in, and it also tells you how to key things in the textbook. So if you're having trouble with that, you can use the book or set up a virtual meeting with me. So for this particular calculator, to put it in degree mode, you're going to go to your mode. You should see it'll be a little D up here at the top, and usually to go into degree mode, we have to press mode and press mode a couple of times until you get where your calculator says degree, rad, grad. So it says the 3 things, okay? So degree, rad, grad. And then you'll select number 1 for degree. So depending on what calculator, if you're not sure how to do it, or you're not sure if your calculator's in degree mode, take a picture of it, send me a picture with your calculator on. I'm more than willing to help you solve that. It will be important, but make sure you know how to put that block calculator in degree mode for your calculations. So first of all, how can we check whether it's in degree mode or not? So the first thing we're going to do is we're going to find out, do you and I both get the same answers when we find the sine of 45 degrees? So to put that in your calculator, you are going to, I'm going to give you the method for the block calculator as opposed to this one. Okay, so we've got 2 different types of calculators. Depending on which one you have, it will go in differently. So for the block calculator, you will first type in 45, then you'll press the sine button, and then you're going to press equals. So 45, sine, and equals. You should get 0.703 If you're not getting 0.0771, so 0.7071, make that a little clearer to see. So again, 45, you'll type in first, and then you're going to press the sign button. You don't have to do any shift or anything. You'll press the sign button and then press equals. Actually, I guess you don't even have to press equals. In some cases, you have to press equals. In some cases, we don't. So, okay, so 45 sign. If you're not sure, hit equals. That will give you the sine of 45 degrees. So let's do the same thing for cosine. So you'll do 35 cos and equals. And you should get 0.8192. Now, whenever you're doing these ratios, if you're finding the sine of 45 degrees, keep 4 decimal places. I'm going to tell you to do that every single time. If you round it too soon, it's going to make your measurements come out off. And you know how important precision is. So you want to keep things precise. So whenever you're finding like a sine of 45 degrees, cosine 35, tan of 80 degrees, 14 seconds, or 14 minutes rather, you always want to keep 4 decimal places in that ratio. So you can just take that as a rule, straightforward. So that covers your block calculator. If you have, I call this one the backwards calculator because we put the angle in first and then we press our sign button. If you're using a calculator like this one, my favorite calculator, because it has a display up here at the top, I call it the forwards calculator. In this case, for this calculator, you do sine, and then you type your 45, and then you would hit equals. Okay, so two different methods for this calculator. It's 45 sine equals. So that's your block calculator. It's the backwards calculator, opposite of the way we write it. For other calculators, it may be 45 and then maybe sine 45. It's important that you use a calculator. I do not want you using your phone for this section simply because you're going to get stuck later. If you only have a phone at home, let me know. But I do know the dollar store still happens to be open, and any calculator that has sine, cosine, and tangent will be sufficient. If your calculator's at school, let us know. We can get you into the building, or we can have it set out in a secure location for you to pick up. Now, for the very last one, we want to find out what is the tan of 80 degrees and 14 minutes. There's a couple ways to do this in your calculator. Your calculator can handle degrees and minutes without you needing to convert it to a decimal. So if you have the block calculator, what you're going to do is you're going to type in 80, and then you're going to press your degree button. So the degree button is this one right here, okay? So you press your degree button, degree, minute, second, okay? And then you'll do 14, and then you're going to press that degree, minute, second button, and then you're going to press tan and equals. You should get for an answer 5.8095. Okay, so that is our decimal. So you can use, and it works for both calculators, if you have that degree, minute, second button, you can use it so you don't have to convert 80 degrees, 14 minutes into a decimal. Now let's say your calculator doesn't have that. If your calculator doesn't have a degree, minute, second button, you need to convert to a decimal. So you would do 14 divided by 60 plus 80. And oops. And if you do that, I wrote down the number, you would get 80.233, and then you would press tan. Okay, you'll get exactly the same answer. I say exactly the same, depending on how much rounding you do, you could get a little variation, so try to keep as many decimals as possible. But if you're converting it to a decimal, I'd say keep 4. 4 should keep you safe. You'll get the same answer regardless of which way. So either convert your degrees and minutes to a decimal, or use that degree minute second button. We'll do a couple of questions with those, although that's not my primary focus today. We'll return to that in a future lesson. So I want to take just a second before we get into calculations. I want you to figure out what possible values could the ratio for sine, cosine, and tangent have. This can help you determine if you're putting your math in correctly, or why maybe you're getting an error in your calculator. So for sine, it's the opposite. So usually the way we write these questions out is we say the sine of our angle is equal to opposite over hypotenuse. Notice I've included the theta symbol to represent our angle. So it's opposite over hypotenuse. We know the hypotenuse is always largest. Because it's always the largest side, this ratio will always be less than 1. Less than or equal. Less than or equal to 1. It will never be greater than 1. It's impossible, because for it to be bigger than 1, the numerator would have to be larger than the denominator. So if your calculator gives you an error when you're calculating with the sine ratio, you probably don't have the hypotenuse in the right place. Cosine is quite similar. So the cosine of an angle is equal to the adjacent side divided by the hypotenuse. Again, we know the hypotenuse is always biggest, so this ratio always has to be less than or equal to 1. The tan ratio, though, it's different. The tan of an angle is equal to opposite divided by adjacent. We can't predict whether the opposite is longest or the adjacent is longest. It's not consistent. This is the only ratio. It can be 0 to greater than 1. Okay? It can go from 0 to greater than 1. It doesn't have a limit. So those are the possible values you could have. So it's possible you could get an error message for sine or cosine calculations if you get your angles in the wrong place, or your sides in the wrong place. That won't be as big an issue today, but in your next lesson, finding angles, it will be something to keep an eye on. So now let's do some calculations. First of all, we're going to find out what is the ratio required to solve each of the following problems. Just let me swap a pen color here for a moment. All right, so which ratio? So I always say start out every question with SOHCAHTOA on the page. First of all, if you don't have it memorized, it will help you memorize it. So start out with that on the page. Sine is opposite and hypotenuse, cosine adjacent and hypotenuse, tangent opposite and adjacent. It's also the order that they go in. First number goes on the top, second number on the bottom. So if I look at this first question, I have x, 28 degrees, and 14. First thing you should always do is label your sides. So 14 is my hypotenuse. It's opposite of the right angle. 28 degrees, this is my subject angle. Next to it is the adjacent side, and over here where x is the opposite side. Now, how would I find what x is? Well, I want an opposite side. So if we look at our SOHCAHTOA ratio, I'm going to write it again just so that I could cross some things off. If I'm solving this question, I'm looking for opposite. I can only use a ratio that includes opposite, so cosine is off the books. It uses adjacent hypotenuse. It's no good to us. How do I decide whether I use sine or tan? Well, I look at the information that I know in the question. I know my angle, but I also know the hypotenuse. I don't know any information about the adjacent, so I can't use the one with adjacent. I need to use sine. So in this case, the ratio we would use is the sine of 28 degrees is going to be equal to, and we don't have to solve it, but we'll write all the information in. So to solve this would be the sine of 28 degrees is equal to x divided by 14. That's how we would set it up. So it uses the sine ratio. From here, it shouldn't be too bad in order to solve it. I didn't actually work out the solution for this because we're going to work the solutions out in several of the future questions, but that's how we would write it. If you want to go back and work it out, feel free. The next question, what ratio should we use? So again, start out by labeling the triangle. So, well, first of all, we can see here that hypotenuse is easy to label and we don't know anything about it. That should give us a good clue. 40 is next to 15, so this is my adjacent, and x is equal to our opposite. Now as I go over and look at my ratios, I don't know, whoops, let's just undo that. I need that line there. All right, we don't know anything about the hypotenuse, so cosine and sine are both out. We know the adjacent, we want the opposite. So this one is going to use tan. So the tan of 40 is going to be equal to, opposite comes first, so x on the top, 15 on the bottom. And then you would solve it using some simple algebra, but this one uses the tan ratio. If you can pick out which ratio, from there, things get pretty easy. Example number 2, now we're actually going to do some full calculations and get each of our sides. Again, I'm going to recommend that you write SOHCAHTOA every time you do a question, just to help you remember. If you happen to have it memorized off by heart and you just want to write it down once, well, I guess I can't monitor too closely. Just make sure you're getting the right answers for us. Now, these questions don't have a lot of decimals. I'm keeping them simple. And then when we get to the last two, we're going to take them more from our trade book. So find the length of the side marked X in this triangle. So first thing we need to do is label the three sides. So we know that this is my hypotenuse. It's the longest side. It's opposite or right angle. 40 is my subject angle, which makes the bottom the adjacent, and X opposite. Now I look, I have hypotenuse, I want the opposite. Which ratio uses both of them? The sine ratio has opposite, uses hypotenuse, and we already know our angle, so we're going to use the sine ratio. So the sine of an angle is equal to opposite over hypotenuse, putting the information into our question. Sine of 40 is equal to x over 8. Now to rearrange this, remember your math from last semester, multiply both sides by 8. The 8's cancel out, and you'll end up memorizing patterns for this. It wouldn't surprise me at all, and I'm fine with that. So you can do sine of 40 times 8 is equal to, you're going to put that in your calculator. So how do we put it in your calculator? You can do it all in one step in your calculator if you want. That can get a little bit tricky. I would suggest writing this sine of 40 out as a decimal. So 40 times 40 and press sine gives us 0.6428. I'm rounding it off, times 8, which gives us 5.1423. You could do it in your calculator all in one step. If you do it in your calculator all in one step, you'll do 40 sine times 8. Okay, so you have to kind of get used to the process. If you want to try it in one step, try it with a few questions that I have examples for and answers for quickly. This just has no decimal places, so I would take this and I would say it's approximately equal to 5 centimeters. Okay, and all I'm doing is matching the precision in the question, and that's a general rule we can use when it doesn't say where to round to, is once you get to the very end for a length, look at the other lengths in the question. If there are no decimals, you can round to a whole number. Unless it says otherwise. If it's 2 decimals, round to 2 decimals. If it's 3 decimals, round to 3 decimals, but do that at the very end of your question. Next one, calculate the length of side AB in this triangle. So side AB, it's actually labeled as X, so it's just the connection point from point A to point B. We want to find out how long is it. So the first thing we're going to do is label the triangle. So opposite is the hypotenuse, opposite the right angle. And then here's my 50 degrees, that's my subject angle. 9 is next to it, so that makes it adjacent. And opposite is X. Now, which ratio should we use? Now, if you look at SOHCAHTOA here, we have adjacent, we want the opposite, we don't know anything about the hypotenuse. So the ones with the hypotenuse are no good to us, so this obviously is going to use tan. So the tan of an angle is equal to opposite divided by the adjacent. The tan of 50 is equal to X divided by 9. It's rearranging just like before. So X is going to be equal to 9 times the tan of 50. Or it doesn't matter what order we multiply in, so that's okay. So you want to put that into your calculator. So tan of 50 here, put an extra number in, so we're going to get 9 times 1.1918. And again, I'm keeping all the decimals in my calculator, so there might be a slight rounding difference if you type it in again. And I get 10.773. You'll notice this is the length. This is my final answer. So I've got no decimals here. So I would say this is equal to 11 centimeters, matching the precision of the question. Okay. So it's really not too hard. This one is probably the trickiest rearranging one, and I probably should have put a few more examples of it in. I'm sorry. There's lots in the worksheet, so please do some extra questions in the worksheet. Look for ones where you have to find the hypotenuse. They're the ones that people make mistakes on rearranging. We will get you more of those in the future. So this one says calculate the length of the hypotenuse in the triangle. So first of all, where is the hypotenuse? We'll label it as X. So there's my hypotenuse. 20 is my subject angle, and 12 is adjacent to it, or next to it, and this is my opposite side. All right, so now we look at our formula. So we want hypotenuse. Tan does not use hypotenuse, so it's out. So it's either going to be sine or cosine. How do we decide which one it is? I look at what side do I have information about. In this case, I know the adjacent side. So I know adjacent, I want the hypotenuse. Cosine makes sense. I don't know anything about opposite, so I can't use sine. So the cosine of an angle is equal to the adjacent side divided by the hypotenuse. So the cosine of 20 degrees is equal to 12 divided by h. We can call it h, we could call it x. You can decide what you want to use for a label there. Notice we're looking for something that's on the bottom. Now this is one of those ones that last semester when we did our rearranging, I said, this is one of those ones that can use the shortcut, and they trade places. So we're going to find that h is equal to 12 divided by the cosine of 20. The long way to rearrange that, you could put it over 1, or you can multiply both sides by h to get rid of that h. Just remember, cosine and 20 are stuck together like glue. One doesn't move without the other. Okay, so I always say they're married together. They gotta stay stuck together. So don't ever separate that cosine and the 20. We'll learn how to do a little separation next week, but it's a little bit more complicated. There's a few steps, okay? So h is 12 divided by cosine 20. You can do this in your calculator in one step. To do it in one step, you would do 12. You're going to press the divide button. Then you'll press 20 cos. Now it's going to give you an answer right away. The answer it gives you is the decimal for cosine. So you need to press equals in order for it to do that division. That's if you do it in one step. Otherwise, what I would suggest doing is saying, okay, it's equal to 12 divided by, and we're going to do 20, press the cosine button, and our number that we get is 0.9397. So I'm going to do 12 divided by 0.9397. And I get 12.77, or since we don't have any decimal places in this question, I'd say the hypotenuse is equal to 13 centimeters. Okay. You could test it. You could try doing it in one step. So this is our one step and this is our two step. You can use either one. For a quick final calculation of a couple questions, I pulled these ones from the textbook Mathematics for Machine Technology. These give us maybe some more decimals that we might see in the machining tray. It also gives us a couple of examples where we see degrees, minutes, and seconds. Now in this particular question, we have 40 degrees and 0 minutes. So we really don't have to worry about the minutes, but it is good to keep an eye out and watch for that. So just watch to see how your angle is recorded. If it's 0 minutes, there's really no need to worry about anything. So we want to find out the length of side B. So the first thing we want to do is label our side. So opposite the right angle, we have the hypotenuse. Across from the subject angle, we have our opposite, and next to the subject angle, we have adjacent. In this particular question, SOHCAHTOA, throw the SOHCAHTOA down. In this question, we don't have our hypotenuse, we don't want the hypotenuse, so that takes these two formulas out of the equation and we're left with tan. So the tan of an angle is equal to opposite over adjacent. We just simply put the information into the question. So the tan of 40 degrees, we can leave out the minute, is equal to opposite, which is B, divided by the adjacent of 6.8. You can leave the decimals out in this particular situation. Just make sure you include 3 decimals in your answer, and anywhere in between where you're rounding, you include at least 3 decimal places. So we're going to I'm going to leave you up to the rearranging part. The B is equal to 6.8 times, because we want B is on the top, so this is the case where it's going to get multiplied, 6.8 times the tan of 40. Okay, take a moment, put that into your calculator and see what you end up with. Don't forget, if you're putting it all in one line, so if you're doing 6.8 times 40, pressing the tan button, you should also press equals after that. You will get for an answer, let me see here, I think I maybe put an error in. Yes, I did. And for an answer, we get 5.706, and it's in inches. So that has me rounded correctly. So that's the length of B. Now, just a quick, how did I know I had an error? So when I first did this question, I got 1 decimal something, and it's just something interesting about a triangle. If you have a 45-degree angle in here, it means the length of your A and your B will be equal. So 40 degrees is close to 45, so I knew my answer should be somewhere close to 6. Okay, it's going to be close to the measurement of the other side. So when I got 1 inch for the other side, I knew, oh, okay, I should put that in my calculator again. Clearly, I've made an error. And I'm not sure exactly what I had done, but obviously I missed something. One final question for this section. We want to find the length of both P and N in this particular triangle. This time we have 49 degrees and 10 minutes. So we need to make sure we know how to put that degrees and minutes in our calculator, and I'm going to recommend using the degree and minute button. If you don't use the degree and minute button, you should convert the 49 degrees, 10 minutes, into a decimal. So that is equal to 10 divided by 60 plus 49. Okay, so 10. We'll put that down. 10 divided by 60 plus 49, and keep as many decimals as you can. In this case, I get 49.16667. So just keep lots of extra decimals. So you can use either degree, minute, seconds. That's going to be more precise, or decimal. If you're using your phone, you may find you have to go to the decimal version. All right, so let's get down to calculating. So to calculate these, let's label our triangle first. So this is my subject angle. I have a hypotenuse opposite the right angle. Next to the subject angle is angle N, which is my adjacent. And across from that, we have our opposite. Opposite, adjacent, and hypotenuse. Now, let's do N first. We'll do alphabetical order. So to find N, I'm leaving letters up. So to find N, what should we do? So we want to find N. N is my adjacent. First thing we'll look at is we don't have opposite or adjacent, so we know we're not going to use tan here. So because we have the hypotenuse, we're either going to use sine or we're going to use cosine. N is adjacent, so it's going to use cos. So we're going to use the cosine of our angle is equal to adjacent divided by hypotenuse, or the cosine of 49 degrees 10 minutes is equal to N divided by 21.090. Rearranging that, you will get N is equal to 21.090 times cos 49 degrees 10 minutes. You can put that in your calculator using your degree, minutes, second button. So in our calculator, I'll give you how to key it in using the calculator that's used for the block. If you don't have that calculator, you may want to use this decimal. So I'm going to type in 21.090. Actually, let me, I guess I don't really need to write down what I'm typing in. So to type it in, 21.090. We're going to press multiply. Then we're going to put our angle in. In this case, we're going to use that degree, minute, second button. So you're going to type in 49 degree, minute, second, 10 degree, minute, second, and then press cosine. After you've pressed cosine, press equals. And this will give you your final answer. So if you're not getting that in your calculator, please send me a message, give me a call, send a text, whatever it happens to be that works well for you. So we get 13.789, and that decimal continues. 3 decimal places given in the question, so we're going to round to 3 decimal places. And that would give us 790 inches. Okay? Now, you're going to find P. In order to find P, we need to find the opposite. So if cosine uses adjacent, we're going to use sine. So sine of our angle equals opposite over hypotenuse. Putting the information in, sine 49 degrees, 10 minutes equals P divided by the 21.090. Squeeze it all in there. It's going to rearrange. You'll notice the equations look the same, so they're going to rearrange the same. So P is equal to 21.090 times the sine of 49 degrees, 10 minutes. So again, if you're putting that into your calculator, 21.090 times 49 degree, minute, second, 10 degree, minute, second. And then you're going to press sine, and then you're going to press equals. And you should get 15.957 inches. Squeeze that in, okay? So N is 13.790, or 13 and 790 thou, and P is 15 and 957 thou. And that finishes off our examples. So when you're picking your ratios, you've got 3 to choose from. Pick the ratio that has the side you want and the side you have. So that's my clue. Process of elimination is absolutely fabulous. Perfect strategy to use. And just for a quick recap, label the triangle sides relative to the angle you know or want. So think about that subject angle. The hypotenuse is always opposite the right angle. Opposite is opposite the subject angle. Adjacent is next to the subject angle. I strongly advise writing SOHCAHTOA down on your paper every time you begin. It definitely helps. It'll help you remember them. It's not the kind of question the kind of equation they're usually going to give on a block exam. Keep 4 decimal places until you get to the end. That's a good general rule for these questions, especially given the precision of your trade. And finally, the process of elimination is a helpful tool. You will always need 2 pieces of information. You'll be solving for the third. So, look at that SOH, CAH, TOA, figure out which of those 3 do I have 2 pieces of information for, and that's the ratio you will select.